Hey, today I'll be explaining question 2 from Leetcode's most recent competition, last moment before all ants fall out of a plank. So, the ants on the plank move in one of two directions, either left or right. They move with the speed of 1 unit per second, and when two ants collide, they turn back and switch directions and continue to move with the speed of 1 unit per second. So let's just get straight into the problem. My first approach during the competition was to create a hash set, or to create a hash map storing the direction and current position of each and every single one of the ants, and then update the time by 1 and accordingly update the hash map. I realized that was not the best solution, and it was really complex, and there was indeed a much more straightforward solution, and that's what I'll be talking about today. One thing you need to understand is that when two ants collide, nothing really happens. And what that means is that when two ants collide, the answer that you return will not be affected essentially. And I know that sounds a little bit complicated because ants are switching and times are changing, but I'll try to explain why and what that means. So given example 1, after 1 second, ant A will move to position 1, ant B will move to position 2, ant C will also move to position 2, and ant D will move to position 3. So when ant B and C collide, as you can see right here, what's really happening is that the path that ant B took was actually transferred to the path of ant C. So essentially, C took on the responsibility of path B. Because after 1 second, if there were no collision, ant B would be facing towards the right and on position 2. And that's exactly what ant C is doing right now after the collision. And the same goes for ant C. If there were no collision, ant C would be facing left on position 2, and that's exactly what ant B is doing. So B took on the responsibility of ant C, and C took on the responsibility of ant B. So in that essence, collision really doesn't affect the last moment where an ant will fall off. As you can see at time t equals 1.5, you increment that another half a second, and A takes on the responsibility of B, and B will take on the responsibility of A. And using that logic, this logic will work for any test case, and using that logic, the solution becomes very straightforward, and simply you would find the max distance in the left array first from the plank size. So let's look at what that means. So max distance in the left array from the plank size would be 3 because ant C is 3 distance away from the end, and 4 because ant D is 4 distance away from the end of the plank. So you store that in a max variable, so that would be 4. Then you take the max distance in the right array from the plank size. So ant B is 3 units away from the end, and ant A is 4 units away from the end. So the max distance is 4, and between the left and the right array, the max distance between both of them, I'll say compute max distance from both arrays, and in this case it would be 4. So you would simply return 4 as your answer. And it's a little bit crazy to think that you could use this solution in such a visually complicated question, but turns out that that's exactly what the solution is. Analyzing time complexity, since you're simply traversing through both arrays, it would be O of n, and the space complexity would just be O of 1. I know this question seems a little bit complicated, but in essence it really isn't. So if you have any questions, just leave them down in the comments below. And if this video helped you in any way, Please subscribe and like, and I'll see you in the next video. Thank you.